so hard that you damage the airy quality of the dough. Take the bottom edge and tuck it in about 2/3 of the way up. Be careful not to flatten the interior. Fold over the top edge and press it down to create a seam. Using the thumb and heel of your hand, seal the dough the length of the piece. Again, be gentle with the interior. Start rolling with one hand in the center and work your way outward with both hands. Create a cylinder-like shape with tapered ends. The seam is like the final weld. It will be on the bottom during baking. In order to preserve the shape of the baguettes, Chef Coppage places them in narrow channels formed in pieces of canvas cloth. Carelessness in the shaping will definitely show in the finished product. The chef demonstrates the shaping of a baguette dough piece that has a crooked seam and an uneven diameter. It's the top piece in this cast of poorly made baguettes. The dough for the pan bread is treated in a slightly different manner. Because the end product is meant to have an even, fine crumb structure, the dough itself is degassed aggressively and tightly shaped. Then the dough rests in metal loaf pans. The divided rolls can be formed by hand into round or oblong shapes. Handle them in an orderly fashion as you prepare them for the next phase. Place them on a clean surface with their seams on the bottom. Don't crowd them. Through practice and experience, you will learn to gently mold the various shapes so as not to damage the dough. Modern bakers have the advantages of mechanization if they need to save time. For instance, if they have to produce a lot of dinner rolls quickly. If you choose, the steps from dividing to shaping can be done in pretty short order by using machines. They divide the dough into exact pieces ready for bench rest. Many bakers use a molding machine to shape their baguettes. Remember that machines are certainly helpful for efficiency, but experienced bakers' hands are ingredients that can't be mechanized. For the final fermentation, the dough pieces are placed in a temperature and humidity-controlled cabinet called a proof box. In this context, the word proof means fermentation. During bulk fermentation, the dough gained its basic flavor and the leavening gases were generated. During bench rest, the dough relaxed prior to shaping. Now, the aim of the final fermentation is to give the dough added volume before it is baked. It needs the right environment to ferment and grow. Typically, the dough will almost double its volume in about an hour and a half at 75 degrees Fahrenheit and a humidity of 75%. The dough will still ferment in a bake shop with similar conditions of temperature and humidity. Let it rest from 1.5 to 2 hours. Assess when it is ready for baking by looking and feeling.
Well, learning to feel for when a product is properly proofed it's like scoring, it's like shaping. It's all through experience, time, repeating it. You know, when it's hot and humid, your dough is going to run a lot faster. When it's cold and dry, you're going to have to give your dough more time.
The proof of the proof is in the bread. This dough has been adequately proofed. It has almost doubled its volume. The finished bread has a porous-looking interior and an off-white color. An underproofed or young dough will produce bread with a dense white interior. It may look almost soggy. The crust will be too thick. An overproofed or old dough will collapse from weakness. Almost ready for baking. First, the proofed pieces are placed onto the loading belt for scoring. Although they do help to create a pleasing appearance, the cuts on a dough piece just before baking are also functional. Scoring provides a weak spot on the dough surface for the bread to expand to its maximum potential and to retain proper shape and rigidity during the bake. Without scoring, the bread will expand unevenly. With some of the dough shapes, a loosely rendered scoring is acceptable. However, with certain shapes, like baguettes for example, the scoring is crucial for achieving the exact properties which define baguette.
So you have to go at it in the right manner with the right angle, but a sharp tool, a light handling of that tool, because you're dealing with a piece of dough that's very fragile.
Use a sharp tool like a serrated paring knife or a lame, which is specifically designed for the purpose of scoring. Handle it carefully. Scoring releases additional expansion during the bake, producing a more open crumb structure. Good scoring provides lightness and volume while improving structure and rigidity. Scoring is a precise art. With baguettes, make the cuts about the same length, roughly 1/4 inch deep, angled slightly. Score the length of the baguette, overlapping the lines of the cuts a bit. This cutaway section shows how proper scoring creates the pleasing ear shape on the baguette. In the finished product, you can see the variations in color where the interior dough has been free to expand and release some moisture, thanks to the scoring. You should be striving for a light structured interior with a well-formed crust. Don't underestimate the importance of scoring to achieve that end. Now to the baking, where you can finally smell the aroma of freshly baked bread. Baking converts the dough into an edible product. This is a hearth or deck oven. Your bake shop may have a rack or convection oven. Ovens and steam are hot. When opening the oven door, be cautious no matter what type of oven you use. This hearth oven is set to 470 degrees Fahrenheit. Inject some steam into the chamber just before and just after the dough pieces enter the oven. The steam helps moisten the dough surface to allow it to expand and to develop into a thin and crunchy crust. In the span of about 22 minutes, heat and steam will transform 12-ounce baguette-shaped dough pieces into finished baguettes. Baking times and temperatures will vary depending upon the density and size of the various shapes. In the minutes the dough is in the oven, several changes take place, some observable, some not. This time-lapse montage shows you roughly what happens during the baking of baguettes, for example. The impact of the oven heat immediately causes the baguette to expand noticeably. That effect is called oven spring. The gases within the dough expand. As the dough temperature goes from about 130 degrees to 176 degrees Fahrenheit, a process called gelatinization takes place. The heated starches absorb moisture from the dough, and the starches swell and firm up, forming the structure of the crumb within the bread. On the exterior, the starches form a shiny, crusty surface. When the surface temperature approaches 300 degrees Fahrenheit, other changes occur to form the reddish-brown color and crispiness of the crust. Through caramelization and what's called the Maillard reaction, sugar and other compounds within the starches undergo a series of complex chemical reactions. The happy result is the rich brown color and intense flavor of the bread. Remember that the heat of the oven evaporates about 10% of the moisture within the dough. About 3 minutes before the end of the bake, vent the oven. This releases some of the humidity so baking continues evenly without burning the crust. This is especially important in humid weather to maintain a crispy crust. Not quite ready to eat. The bread must cool. It is exciting to hear the crackling of the bread as the crust takes its final shape. Check it by tapping the loaf. You should hear a hollow, resonant noise. That means a light, not a heavy, wet interior. You may place the loaves on a cooling rack or in baskets. By placing the loaves in a vertical position, you are letting air circulate around them. Excess moisture will evaporate from the top. The bread will assume its final structure, and then it will be ready to eat. Check the quality of the bread.
Once it's properly cooled, then it's able to be evaluated. When we evaluate the bread, we check the following criteria. We check the shape, we check the color, we check the crust, we check the slicing capabilities of the bread, Then we go into the interior and we check the aroma and the crumb and the taste, and then an overall total impression of the product. From the lean dough, we've produced some boules, or ball shape, some hard dinner rolls, and some loaf bread. The main difference, other than visual symmetry and shape, is going to be in the interior. The finest one, tightest texture, is going to be the loaf bread, because when I shaped that, I really took as much of the air pockets out as possible. The boule is going to be similar to the baguette, but with a thicker crust. Because of its round shape, it's going to be exposed to more heat, so there's going to be more caramelization and hardening of the crust. And the dinner rolls, or petit pain, small breads, are going to be a very fast fermenting and baking product, but we still have a good difference in color from where it was split. When I look at the loaf bread, the sound is not as hollow, it's more tight. Again, based on the way I shaped it. And it was also baked in a pan. So when I slice the interior, I have a hard crust to go through, but now I have a very fine crumb line. Some large air pockets, but the majority are very small. Okay, when I check the quality aspects of the baguette, I first look at the shape. The baguette basically refers to a wand shape, so I want a long, tapered end. It should not be crooked or excessively bulbous on any part of the baguette. I also then look at the color, and the color should be very golden brown, almost yellow-like. Everywhere should be golden brown except in the surface where it's been scored, which will be a little lighter because of the lack of exposure to heat and moisture during baking. Then I go to the crust. The crust should be a hard crust. The next criteria would be the slice. Looking at the interior, the feel, checking the cell structure. If you look at the bottom, you can see where it has tried to lift off during the baking, or that oven spring or oven kick. And just a different size of the holes. Some are large, some are small. After evaluating the crumb, then I'm going to check for the aroma. I'm going to smell the interior along with the exterior, but I want to pick up for a wheat-like aroma without a yeast or alcohol flavor in that product. When I check for taste, I check for that nutty, wheat-like aroma, but I check, how does it chew? Is the crust hard? Is the interior chewy? As opposed to being soft and gummy or homogeneous. I want that. I want to feel the bread, and I want it to leave a good taste in my mouth. When you look at the total impression of the baguette, it's like walking into a bakery with your hard-earned money. So you look over the counter and you look at all the baguettes, and then when you take it home and you share it with your friends or your family, they all know that you know what you're looking for in that product, in a quality-oriented baguette.
One of the best things about knowing how to bake bread is being able to eat it when it's fresh.
Because it doesn't have a long shelf life, if you learn to appreciate the way it tastes when it's fresh, you'll want to have that product on a regular basis.
Review the 12 steps of basic bread baking that we have demonstrated. To show you how to increase or decrease the dough yield, let's look at the formula we showed you earlier. First, simplify the math and convert all of the weights into ounces, the lowest common denominator. This example is easy because the flour weight becomes 100 ounces. You see the other ingredients follow relative to the formula's percentages. If you want to increase the dough yield, start by increasing the amount of flour. That amount is always 100%. With 10 pounds of flour, for example, convert it to 160 ounces. Then apply the percentages to the other ingredients. Start with the water. Convert 65% to its decimal form, 0.65, and multiply that by 160 ounces to get 104 ounces. Use the same principle for the salt and the yeast. With the yeast, for example, multiply 160 ounces by 0.015, the decimal form of 1.5%, to get 2.4 ounces of yeast. In a bake shop, the amount of dough that will be produced is the starting point for the calculations. From there, the baker applies the baker's percentage to determine first the amount of flour and then the amounts of all the other ingredients. Earlier, we showed you how to calculate the water temperature to achieve the desired dough temperature. You need to figure out the friction factor for your mixer by performing a series of tests. The friction factor will be affected by batch size, mixer type, mixing time, type of dough, and the temperatures of the mixing bowl and the room. To conduct your test, make a trial batch of dough. Put the room, flour, and water temperatures into the equation. Then check the final dough temperature. The remaining variable is the friction factor for that batch. Do this test several times and note down the results. You will then have a good idea of the friction factor to use under those conditions. With practice, you will learn to make the adjustments that suit the conditions of your bake shop. Now, get the best ingredients, get organized, and get started. Enjoy.